Our objective for this lesson is to graph rational functions. I suggest that you watch my videos on intercept zeros, asymptotes, and wholes, as well as solving rational inequality to fully comprehend this lesson. Let's start. Let us graph y is equal to x minus 2 all over x plus 2. Step 1. Express the function in factored form. Since our given is already in simplest form, then we simply have to copy it. Step 2. Simplify the function to lowest terms. Again, this is already in simplest form. Step 3. Find whole if there is any. Since there is no common factor in the numerator and the denominator, then there is no whole. Step 4. Let's start with the x-intercept. Let's have the given, and let us replace y with 0. So 0 equals x minus 2 all over x plus 2. To solve for x, cross multiplication. 0 times x plus 2 is 0 equals x minus 2. Moving negative 2 to the other side, we have 2 equals x. Our x is 2, our y is 0. Therefore, our x-intercept is 2, 0. Next, y-intercept. Let's have the given, and let us replace all x's here with 0. So we have 0 minus 2 all over 0 plus 2. This is negative 2 over 2, and that is negative 1. So our x is 0, our y is negative 1. Therefore, our y-intercept is 0, negative 1. Next step, find VA, HA, or SA if there is any. Let us start with the vertical asymptote. Let us equate the denominator to 0. So x plus 2 equals 0. Moving 2 to the other side, x equals negative 2. So our vertical asymptote is x equals negative 2. Now, for the horizontal asymptote, let us compare the exponents. The degree of the numerator is 1 and of the denominator is also 1. Since they are equal degree, let us compare the numerical coefficient. This is 1 over 1. So, our horizontal asymptote is y equals 1. And now for the slant asymptote, since we already have horizontal asymptote, then we do not have a slant asymptote. Step 6. Identify any points intersecting a horizontal or slant asymptote. Use the reduced equation and horizontal asymptote. Our function is already in simplest form, and the horizontal asymptote that we get is y equals 1. So we substitute 1 here. So 1 equals x minus 2 all over x plus 2. Cross multiplication, so we have 1 times x plus 2 is x plus 2 equals x minus 2. X and x here will be cancelled out, leaving us with 2 equals negative 2. But they are not equal. Therefore, there is no point of intersection on the horizontal asymptote. Step 7. Construct a Cartesian coordinate system and locate important details. So let's have the Cartesian plane. And let's start plotting important details. First one, x-intercept 2, 0. For the x-intercept, we draw light vertical line. Next, y-intercept, 0, negative 1. Next, vertical asymptote, x equals negative 2. So for vertical asymptote, we draw vertical dashed line. And last one, horizontal asymptote, y equals 1. So let us draw horizontal dashed line. Now that our important details are complete, let us determine how many regions do we have. So we have 1, 2, 3 regions. Step 8. Let us create the table. First, let us recall our function. Then, let's have the table. The first column is the region, followed by interval, and then x value. X minus 2 is our numerator. X plus 2 is the denominator. And the next one is the quotient of numerator over the denominator. And the last column is the interpretation. Now, let's have our CCS together with its important details. So, from here, we can see that we have 3 regions. That's why I have region 1, 2, and 3 here. Let's have region 1 first. The interval of region 1 is from negative infinity up to negative 2. Negative 2 is not included because there is a vertical asymptote here. So, negative infinity to negative 2. Let us assign any value from this region. Let us say negative 3. Then we substitute. Negative 3 minus 2 is negative 5. We are only after the sign, so negative. Negative 3 plus 2 is negative 1. And then we have negative divided by negative is positive, and if it is positive, the interpretation is above the x-axis. Now let's have region 2. The interval is from -2 up to +2. 2 is included. That is our x-intercept. So -2 to +2. Let us assign any value here. So let us say 0. So 0 minus 2 is negative. 0 plus 2 is positive. Negative divided by positive is negative. If it is negative, the interpretation is below the x-axis. For the last region, region 3, the interval is from +2 up to +infinity. So let us assign any value from region 3. Let us say +3. So 3 minus 2 is positive. 3 plus 2 is also positive. Positive divided by positive is positive. Therefore, our interpretation is above the x-axis. Now, let us sketch the graph. For region 1, our interpretation is above the x-axis. Notice that I have horizontal asymptote and vertical asymptote here. So my graph should get closer and closer to these lines. So let us graph now. So my graph is above the x-axis and it approaches my two asymptotes. For region 2, the graph should be below the x-axis. And notice in region 2, I have y-intercept and x-intercept. My graph should pass those 2 points. So let's graph. Passing through y-intercept and then x-intercept. Now, when it enters region 3, the graph should now be above the x-axis. So here is our x-axis, so above x-axis. But I have a horizontal asymptote here that I should not cross. So let's graph above x-axis and follow through horizontal asymptote. This graph is done manually. Now let us see if it is graphed in a graphing application. Here is our graph. In graphing, you may use applications such as GeoGebra or Desmos. Now let us put the important details of our graph and let us compare it with our graph earlier. You can see that indeed there is a resemblance in these two graphs. Let's have another one. So first step, express the function in factored form. So the factors of x squared plus x minus 12 are x plus 4 and x minus 3. While the factors of x squared minus 4 are x plus 2 and x minus 2. Next step, simplify the function to lowest terms. Since there is no common factor in the numerator and the denominator, then we just have to copy the factored form. Step 3, find whole if there is any. Again, there is no common factor, so there is no whole. Next step, let us find the x and y intercepts. Let's start with the x-intercept. Let us recall our function. Now, let us set y be equal to 0. So 0 equals. And then cross multiplication, x plus 2 times x minus 2 times 0 is 0 equals x plus 4 times x minus 3. So we have two factors here. We're going to equate each one to 0. So x plus 4 equals 0. So x equals -4. Our x is -4. Our y is 0. Therefore, our point is -4, 0. Another factor, x minus 3 equals 0. So x equals 3. Our x is 3. Our y is 0. Therefore, the point is 3, 0. Now for the y-intercept. Again, our function. This time, let us replace all x's here with 0. So this will be cancelled out, leaving us with -12. And for the denominator, we'll only have -4. -12 divided by -4 is +3. Our x is 0. Our y is 3. Therefore, our point is 0, 3. Next step, find the vertical, horizontal, or slant asymptote if there is any. Let's start with the vertical asymptote. All we have to do is to equate our denominator to 0. So first factor, x plus 2 equals 0, x equals -2. Second factor, x minus 2 equals 0, x equals positive 2. So we have two vertical asymptotes, x equals negative 2 and x equals 2. For the horizontal asymptote, let us examine the exponents. Both numerator and denominator are raised to the second power, so let us compare the numerical coefficients. Here, the numerical coefficient is 1, and here is also 1. So we have y is equal to 1 over 1. Therefore, our horizontal asymptote is y equals 1. And for the slant asymptote, since we already have horizontal asymptote, then we do not have a slant asymptote. Next step. Step 6, in here we are going to make use of our reduced equation as well as the horizontal asymptote that we solved earlier. So let's substitute 1 for y. Cross multiplication, so 1 times x squared minus 4 is x squared minus 4 equals x squared plus x minus 12. So x squared here and here will be cancelled out. Let us move negative 12 here. So what will be left here is simply x. So here we have negative 4 plus 12 equals x. Negative 4 plus 12 is 8. So x is equal to 8. Now our x is 8, our y is 1. Therefore, our point is 8, 1. Step 7. Let us construct a Cartesian coordinate system and locate important details. Let's start off with our x-intercepts. We have 2, negative 4, 0. Do not forget to draw light vertical line. And 3, 0. Another light vertical line. Then we have our y-intercept, 0, 3. Next, our vertical asymptotes. We have 2 again. X equals negative 2. Let us draw vertical dashed line. And x equals 2, another vertical dashed line. Then we have horizontal asymptote, y equals 1. So we have horizontal dashed line. And finally, point 8, 1. Let us draw also a light vertical line in our point of intersection with the horizontal asymptote. And let us now determine how many regions we have. We have 1, 2, 3, 4, 5, 6 regions. Now, let us create a table. Let us recall the factored form of our function. Here is our table and the Cartesian coordinate system with the important details. From here, you will notice that we have 6 regions. I have it here, 6 regions, followed by interval, the x value. These 2 are the factors of the numerator, and these 2 are the factors of the denominator. This one is the quotient of the numerator and the denominator, and the last column is for the interpretation. So let's start with region 1. The interval is from negative infinity to negative 4. Negative 4 is included because this is not a vertical asymptote. So negative infinity to negative 4. If it is included, we make use of bracket. Let us assign any value from region 1. So let's have negative 5. Negative 5 plus 4 is negative. Negative 5 minus 3 is negative. Negative 5 plus 2 is negative. Negative 5 minus 2 is negative. I'll teach you a technique to get the sign here. Simply count the number of negatives. If it is an even number, then the sign here is positive. So let's count 1, 2, 3, 4. And 4 is an even number. Therefore, our sign here is positive. And if it is positive, the interpretation again is above the x-axis. Let's have region 2. So region 2 is from negative 4 to negative 2. Negative 2 is not included because we have a vertical asymptote here. So negative 4 to negative 2. Let us assign any value from region 2. Easiest is negative 3. Let us substitute. Negative 3 plus 4 is positive. Negative 3 minus 3, negative. Negative 3 plus 2, negative. Negative 3 minus 2 is negative. Let us count the number of negatives. 1, 2, 3. 3 is an odd number. So we have here negative. If it is negative, the interpretation is below the x-axis. Let's have region 3. Region 3 is from negative 2 to positive 2. Both are not included because these two are vertical asymptotes. So we have negative 2 to positive 2. Let us assign any value from region 3. Easiest is 0. Let us substitute 0 plus 4, that is positive. 0 minus 3 is negative. 0 plus 2 is positive. 0 minus 2 is negative. Count the number of negatives. 1, 2. That is an even number, so this is positive. Interpretation above the x-axis. Next, let's have region 4. So region 4 is from positive 2 to positive 3. Positive 2 not included, positive 3 included. So we have 2 to 3. Not included, parenthesis, included, bracket. Assign a value from region 4, let us say 2.5. Let's substitute 2.5 plus 4, positive. 2.5 minus 3, negative. 2.5 plus 2, positive. 2.5 minus 2, positive. There is only one negative and 1 is an odd number. Therefore, this is negative below the x-axis. Next, region 5, that is from 3 to positive 8. So both are included, so 3 to 8. Let us assign a value from region 5, let us say 4. 4 plus 4 is positive, 4 minus 3 is positive, 4 plus 2 is positive, 4 minus 2 is positive. So there is no negative, all positive, therefore this is positive above the x-axis. And last one for region 6, that is from positive 8 to positive infinity. So 8 to positive infinity. Let us assign a value. Let us say 9. 9 plus 4 positive. 9 minus 3 positive. 9 plus 2 positive. 9 minus 2 positive. Once again, no negative. So this is positive above the x-axis. Now let us sketch the graph. So let's start at region 1. It says it should be above x-axis. So here is our x-axis. So for region 1, above this line, it cannot pass through the horizontal asymptote. There is no point of intersection. And it should touch the x-intercept. So let us graph. Okay. Now, when it enters region 2, the graph should be below x-axis. So below x-axis is somewhere here. And I have here a vertical asymptote, so my graph will just get closer to that. Let's graph. For region 3, the graph should be above x-axis. So here is region 3. I have y-intercept. My graph should cross that one. And I am bounded with 2 vertical asymptotes, so my graph will just get closer and closer to those asymptotes. Let's graph. That's it. For region 4, graph should be below x-axis. So here is region 4 below x-axis, vertical asymptote, x-intercept. The graph should cross that one. When it enters region 5, it should be above the x-axis. So here is region 5. Again, I cannot pass through the horizontal asymptote. There is no point of intersection. So I will just follow the horizontal asymptote. And finally, when it enters region 6, it says here the graph should be above x-axis. So here is the region 6. I have a point of intersection here, so I can pass through the horizontal asymptote, but still I'm going to follow the horizontal asymptote. So let us graph at region 6. And that is the graph of our function. Let us compare this to a graph that was done in a graphing app. So this is the graph. Let us recall the important details. And this time, let us compare this to the graph that we did manually. So you can see that there is indeed a resemblance in these two graphs. Let us have one more. Step 1. Express the function in factored form. The factors of the numerator are x plus 5 and x minus 2. The factors of the denominator are x plus 5 and x plus 3. Step 2, simplify the function to lowest term. So since there is a common factor, we can cancel it now, leaving us with y equals x minus 2 all over x plus 3. Step 3, find the whole if there is any. Since there is a common factor, then there is a whole. To find the x value of that whole, let's make use of the common factor and equate that to 0. So x equals negative 5. For the y value, we're going to substitute this negative 5 in our simplified function. So we have y equals negative 5 minus 2 all over negative 5 plus 3. Negative 5 minus 2 is negative 7. Negative 5 plus 3 is negative 2. So negative 7 over negative 2. Negative divided by negative is positive. So this is just equal to 7 over 2. Our x is negative 5. Our y is 7 over 2. Therefore, the whole is negative 5, 7 over 2. Next step, let us find the x and y intercepts. Let's start with the x-intercept. So we're going to make use of our simplified function. Let us let y be equal to 0. So 0 equals x minus 2 all over x plus 3. Cross multiplication, 0 times x plus 3 is 0. 0 equals x minus 2. Moving negative 2 to the other side, so we have x equals 2. Our x is 2, our y is 0. Therefore, our x-intercept is at 2, 0. Now, for the y-intercept, we are going to replace all x's here with 0. So we have 0 minus 2 all over 0 plus 3. 0 minus 2 is negative 2. 0 plus 3 is 3. So y equals negative 2 over 3. I can place the negative sign here in front like this. So my x is 0 and my y is negative 2 over 3. Therefore, the y-intercept is at 0, negative 2, 3. Next step, let us find the vertical, horizontal, or slant asymptote if there is any. Let us start with the vertical asymptote. We are going to make use of the simplified function. Let us equate the denominator to 0. So x plus 3 equals 0, x equals negative 3. Therefore, our vertical asymptote is x equals negative 3. For horizontal asymptote, we just have to compare the degree of the exponents. The numerator and the denominator are both raised to the first power, so let us compare the coefficients. The numerator has a coefficient of 1, the denominator is also 1. So y equals 1 over 1. Therefore, our horizontal asymptote is y equals 1. And for the slant asymptote, since we already have horizontal asymptote, then we do not have a slant asymptote. Step 6. For this step, we're going to make use of our reduced equation and the horizontal asymptote that we solved earlier. Now let us substitute the value of y in here. So 1 is equal to x minus 2 all over x plus 3. Cross multiplication, 1 times x plus 3 is still x plus 3 equals x minus 2. So x here and here will be cancelled out, leaving us with 3 equals negative 2. But 3 is not equal to negative 2. Therefore, there is no point of intersection on the horizontal asymptote. Step 7, let us plot important details in our Cartesian plane. Let's start with our x-intercept to 0. Don't forget to draw light vertical line. Then y-intercept 0, negative 2/3, approximately 0.67 negative, so here. And then we have vertical asymptote, x equals negative 3, vertical dashed line. Then horizontal asymptote, y is equal to 1, horizontal dashed line. And then we have a whole at negative 5, and 7 over 2 is 3.5. So negative 5 and 3.5 is here. Now let us determine the number of regions. We have 1, 2, and 3. 3 regions. Now let us create the table. Let's recall our simplified function, and here is our table. So the interval of region 1 is from negative infinity to negative 3. Negative 3 is not included because this is a vertical line. So negative infinity to negative 3. Any value from region 1, let us say negative 4, let us substitute. Negative 4 minus 2 is negative. Negative 4 plus 3 is negative. So there are two negatives, therefore this is positive. Interpretation is above the x-axis. For region 2, that is from negative 3 to positive 2. 2 is included, so negative 3 to positive 2. Not included, parenthesis, included, bracket. Let's assign any value from region 2. The easiest one is 0. So 0 minus 2 negative, 0 plus 3 positive. 1 negative, so this is negative, below the x-axis. And for region 3, from positive 2 to positive infinity. Any value from region 3, let us say 3. 3 minus 2 positive, 3 plus 3 positive. No negative, only positive. Therefore, this is positive above the x-axis. Now, let us sketch the graph. So, for region 1, the graph should be above the x-axis. So, here is our x-axis. So, the graph in region 1 should be above this line. I have two asymptotes here. So, the graph should approach these asymptotes but will not pass through this because this is a hole. So let us graph in region 1, and that's it. Now for region 2, it says here the graph should be below the x-axis. So here is region 2. The graph should be somewhere here. I have a vertical asymptote. I should pass through the y-intercept as well as the x-intercept. So let us graph. And when it enters region 3, it says here it should be above the x-axis. So here is region 3. And I have here a horizontal asymptote. I cannot cross over because there is no point of intersection. So I will just follow the horizontal asymptote. Let's graph. And that's it. This is the graph of our function. Let's compare this with the one made using a graphing application. Let's recall the important details. And let us compare it with our graph earlier. This shows that our graph is correct. As a summary, here are the steps in graphing rational function. Now it is time to check your understanding. Pause this video for more time. Here is the solution. Steps 1 to 3. Step 4, we have two x-intercepts and one y-intercept. We have one vertical asymptote. We do not have horizontal asymptote because the degree of the numerator is greater than the degree of the denominator. So instead, we have slant asymptote. Next step, we do not have point of intersection on the slant asymptote. And here are the important details on the Cartesian plane. Here is the table. And here is our graph. So these are the two x-intercepts, and this is the y-intercept. This is the vertical asymptote, and this is the slant asymptote. Gets?